Today's lesson is going to deal with a thing called annuities. You can think of annuities as mortgages or payments or savings for future investments. You're looking for the future amount of a certain amount of money. So we're going to do the same thing, except this time we're going to be using deposits as one extra variable in our calculation. Now, with annuities, an annuities is a series of payments or equal deposits into an investment made at regular intervals, such as each month, each year, semi-annually, weekly, monthly, or daily. The amount of an annuity is the value of deposits at the end of the annuity. This is the example of the actual equation for an annuity. A is equal to big R, which really represents the payment, 1 plus I to the n, minus 1, n bracket. Then divide by, bracket, the variable I. Now, I is the same variable I that we used in our previous compound interest type problems, and is the same thing as we used before. But R, big R, stands for the deposit that we make every month. Now, let's continue. This formula is only used if the deposit frequency is the same as the compounding frequency. So we always, every time we do these problems, there's only one way of doing it. The compound frequency is the same as that. Now, listen very carefully. The acronym that we'll use to start this problem set will be AARON. AARON with 2 R's. That's A, big R, little r, I, and N. So for our problem here we have determine the amount of an annuity if $500 is deposited. Deposited, anything that's deposited every month is called our big R. This is what our payments are at the end of each month for the next 20 years. Because it says we're paying at the end of each month for the next 20 years, that tells us our compounding number. Okay, so boom, boom, boom. So this happens for 20 years. This represents the years that this goes on for. But then this, and it says, now this says at the end of each year. So that represents our compounding number in this case. Our compounding number is 1. So now when we substitute, we don't know what our final answer is, so that's what our future value is. We do know what our deposit is, it just happens to be $500. We do know what our rate is, it's 5 divided by 100, which is equal to 0.05. But then we do know its I value. Its I value is compounded annually. Boom. Our compound number is annual. And the first payment is what made 1 year from now. So basically what we're going to do is we're going to take 0.05 and we're going to divide by 1. But then we're going to take the 20 years. Was it 20 years? 20 years. 20 years. And we're going to times it by 1. And we're going to get 20. Always start with your equation. And we'll have the following. A equals big R, double bracket, 1 plus I to the n minus 1 divided by I. Now when we substitute, we get the following. A is equal to 500, bracket, bracket, 1 plus 0.05 raised to the 20 minus 1, end bracket. This is important. If you don't put the end bracket, the numbers don't come out properly. Divided by I, which is 0.05 when we simplify it. Once we punch that into our calculator, we get the following answer. $16,532.98. And there is our final answer. For the next problem, we'll do exactly the same thing. We'll do exactly the same analysis. We must always bring our ARIN with us. ARRIN. Now this problem says determine the amount of annuity of 1,000 deposited semi-annually for the next 10 years. Now, guess what? We've just identified our payment, which is $1,000. We've just identified our compounded number, which is, well, because it's semi-annual, it's 2. Now, the interest rate is 3% compounded semi-annually, and the first payment will be made 6 months from now. So let's begin. The R value is 0.03. The I value is going to be 0.03, and we're going to divide by 2. Now you can simplify that pretty easily. Most times you can simplify it easily. Sometimes you can't get a nice number, so I usually just write 0.03 over 2. Or I get an answer like this, 0.015. N is basically this thing. It says it happens in 10 years. So we're going to take 10, and then our comp number is 2, so we're multiplying by 2. So we get 20 years. 20 compounding payments. Every time we start these problems, we'll always start by writing our equation. Now, I'm going to substitute using this instead so that you kind of see how it would look. So we're going to start by writing 1,000, double bracket, 1 plus 0.03 divided by 2 raised to 20 minus 1, and then we're going to divide by 0.03 over 2. You'll notice that I put brackets around this fraction. The reason why we put the brackets around the fraction is that if we don't do that, we're going to be timesing by 2 at the bottom and dividing by 2 and then dividing by 2, and then the whole set of numbers that we had calculated on the top get messed up. So once we punch this in our calculator, you're going to get the following. You're going to get about 23,123.67 for our total amount that we paid out for the entirety of this annuity. Question number 3 is similar. Let's see what happens here. So it says determine the amount of annuity if it's deposited at the end of each month for the next 20 years. The interest rate is 4% compounded monthly, and the first payment will be made a month from now. So we'll start. Anytime we have an annuity, we're going to go and bring out our ARIN. A-R-R-I-N. As we read through, this represents our deposit. So that is our R value. So we're going to put 40 here. Our big R value. At the end of each month for the next 20 years. So 20 years. Oh my goodness. Look, this is our compounding number. When it says monthly, that means that our compounding number is 12. Oh, and look here, its rate is 4%. So the rate is 4%. So 0.04 is our rate. And our interest, our I value that we calculate for a month is going to be 0.04. And then we're going to divide that by 12. Now, as for N, we'll go and calculate N. N is 20 years. So we got 20 years. And then we're going to times that by 12 because there's 12 months in every year. And that gives us 140. Always start by writing our equation. A is equal to R, bracket, bracket, 1 plus I to the n minus 1 divided by I. Substitute directly in, so we got 40, double bracket, 1 plus, well, 0.04 divided by 12. We'll keep as many significant digits as we can, raised to the 240. Subtract 1, and then we divide by bracket 0.04 divided by 12 and bracket. Well, this equals $14,670.99, and that's how much money we make at the end of 20 years. Next, we have another problem. A common strategy to build wealth for retirement is to pay yourself first. This means take 10% of your monthly income and invest it before you spend any. If you took $3,300 every month from the age of 25 to 65 and invested at 5% compounded monthly, how much would you have for your retirement? Well, the first thing that we have to do is we have to basically go to our financial advisor, Aaron, and then we're going to tell Aaron all the stuff we know about this. So, since we have $300, we're going to basically save $300 every month, so that is what our R value is. For N, we're going to start with 40, but because it's every month, we're going to basically multiply that by 12. Now, as for R, R is 10%, which is nope, it's not 10%. R is actually 5%. Which is equal to 0.05. And I is going to be 0.05, and we're going to divide that by 12 since we're paying monthly. As usual, we always have to start by writing our equation. A is equal to R bracket 1 plus I to the n minus 1 and bracket divided by bracket I. These brackets that are on the bottom of the fraction are the most important thing in the entire equation. If you don't do that, your numbers will never come out right. So now, let's do the substitution. After doing the appropriate substitution, you're going to end up with the following when you punch that in your calculator. Now, I need you to remember, when you divide, when you do all of this, you must go divided by bracket 0.05 divided by 12, and you're going to get the following answer: $457,806.05 for our total amount of money saved over 20 years. So your homework for today is based on these questions, which I prepared for you online. Good luck. Now, the last thing I want you to remember is this thing called contributions. Let's go and do that right now. If I wanted to find out the total contributions that I put into my funds, right? what I would do is I would say that is equal to n times the big R value. So 300, so if I take 300 and multiply it by, which gives us 480 times 300, which gives us our total contributions, $144,000. In order to calculate the interest that's made on something like this, we basically say the interest is equal to, well, the original amount minus the contributions. Which is just going to be, well, 475,806.05. And we're going to subtract that from 144,000. And we end up with $313,806.05 as our interest made on this investment over the years. Now, good luck. That's the homework that we have for you for work. Good luck, guys.